Impact parameter B. Rutherford atom model. Alpha particles are allowed to hit the atom. Do you know why some alpha particles bounce back strongly in Rutherford experiment while others just bend slightly? The secret lies in something called the impact parameter. Here you have the nucleus. The alpha particle is coming. This is at very large distance. When it allowed to move, it slightly bends when it approaches the nucleus and takes the path shown. Now, if this nucleus is absent, then this alpha particle would go in straight line. This is the direction of alpha particle at a very large distance. This line is very important for definition of impact parameter. This straight line, this dotted straight line gives the direction of alpha particle at a very large distance. Let us draw a perpendicular line to this direction from the nucleus. This perpendicular distance is called B, known as impact parameter. And we draw another dotted line which gives the direction of deflected alpha particle that makes an angle theta with the direction of alpha particle at very large distance. This theta is called scattering angle. Definition. Imagine an alpha particle is shot towards a gold nucleus. The impact parameter B is the sideways distance from the nucleus to the particle's path if it didn't get deflected. The impact parameter B is the sideways distance from the nucleus to the particle's path if it didn't get deflected. Smaller the impact parameter, closer it goes to the nucleus. That means stronger the repulsion, which results larger the scattering angle. The impact parameter B is less. Then what happens? Then alpha particle approaches very close to the nucleus. Then it experiences a strong repulsion. Then the scattering angle will be large. On the other hand, larger the impact parameter B, then it stays farther from the nucleus, then weaker will be the repulsion, then the deflection will be very small. When the impact parameter B is large, then alpha particle comes far from the nucleus. Thereby it experiences less repulsive force, thereby it is deflected with less angle. The definition. The perpendicular distance between the center of the nucleus and the initial direction of velocity of an alpha particles when it is at far distance. The perpendicular distance between the center of the nucleus and the initial direction of velocity of an alpha particle when it is far away is called the impact parameter. Relation with the scattering angle theta. The impact parameter B equals k times cot theta by 2. Here k is 1 upon 4 pi epsilon naught 2 z e square divided by m v naught square. Let us learn what are all the terms. Z, the atomic number of the nucleus. E, charge of an electron. M, mass of the alpha particle. V naught, Initial velocity of the alpha particle, theta. Scattering angle. Smaller the value of B, larger the scattering angle. Then larger the value of B, smaller the scattering angle. Remember this. The impact parameter and scattering angle are in the inverse relation. Physics meaning. B equals K times cot theta by 2. Impact parameter decides how close an alpha particle goes near the nucleus and therefore how much it gets deflected. Rutherford scattering experiment is explained by this relation. NEET tips. B equals K times cot theta by 2. In NEET, questions often ask, if impact parameter increases, what happens to the scattering angle? The answer is simple, it decreases. Keep this inverse relation in mind. Impact parameter and scattering angle are in inverse relation. B equals K times cot theta by 2.